So throughout fundamentals of data engineering, you guys hammer home the importance of latency, of focusing on latency. So why is latency such a central concern for a data engineer?
Yeah, it's not just a concern. It's also, I think the big theme would be understanding trade offs around latency. And one of the mistakes we see rookie data engineers make when they're migrating from software development is using a transactional database to try to solve data engineering problems. It can work okay, but the problem is that a transactional database is designed to deliver extremely low latency on transactions. It's very, very good at that. It's not as good as at scanning large amounts of data. And so the compromise you make is you move to like a columnar database, for example, where updates of data are slow and typically queries take a while to run. They might take like half a second or a second to run. But now you can efficiently scan, like a petabyte of data instead of looking efficiently at just a small amount of data. And that's just one example. I think the point is that as a data engineer, you're always thinking about what your latency compromises are so that you can essentially optimize around the cap theorem to get the kind of result that you need. And the same would apply if you're working with streaming technologies. The same would apply if you need, true near real time. What are your latency trade-offs in the different parts of the pipeline? What do you think, Joe?
Yeah, I think it's good. I mean, there's definitely a lot of I would say mistakes of omission as opposed to
Yeah,
mistakes of commission. Just
Right.
simply not knowing how to use proper tools that contribute to latency. But
yeah.
the broader question, okay, so why is latency important? Why is low latency important across the data engineering lifecycle? It's because you want to reduce time to value, right? So if it you always want to assess the trade-offs of am I able to make is the downstream stakeholder able to either make an automation or an analytical decision faster and better than they were if I did something else, right? And so it really starts at the place where data is generated and goes all the way to the time data is delivered. That should be as low of latency as possible, unless there's some compelling explanation as to why that shouldn't be. And there might be a reason why you want to actually have larger delays, but the default assumption should be you want to have things happen as quickly as possible.
Right.
um, and this will tie into some other things we'll talk about in a bit. But it's just data is one of these things where if you can capitalize on it from the point of conception to use in a much faster way, why would you not do that? That would seem like kind of a waste of time, no pun intended.
Excellent. Yeah, yeah. That makes sense. Makes perfect sense. So we need to be aware of latency trade-offs for the given pipeline that we're building. But generally speaking, faster is going to be better as a default assumption.
That doesn't mean you have to do faster things, dumber things faster, though, right? And so that which does happen as well.
Right.
Yeah, and fast depends on the context, right? So, like for an analytics stakeholder, 10 seconds, 3 seconds might be really, really fast. Whereas in an application where you need to do transactional updates, over 100 milliseconds might be really, really slow.
Right.
Yeah. Now, I guess it also depends on like the question you should always ask yourself is like, what action am I going to take if I get data
Yes.
faster, right? So, like Matt points out, sometimes it's 10 seconds. Sometimes maybe it might be 10 days, frankly, for if it's a report that it's just a historical report. But it really comes down to the use case. But again, our default assumption is it should be speed. Fast is good, right? Slow
Yeah.
kills. So
We'll sometimes have clients, though, come to us saying, hey, we need real time. And it's like, okay, that seems kind of weird for your business. Like, what do you mean by real time? They're like, oh, 2 days. 2 days is real time in some cases. So, yeah, you have to
Right.
understand the requirements. Like Joe said, optimize to go fast if you can.